Alright, so our next problem is number 8 for the team round. And the problem is to find one set of integers a, b, c, and d with a, b, c less than 10 to the power 5 and a cubed plus b to the 4th plus c to the 5th equals d to the 11th. So at first glance it looks really complicated with the 11th power. It's almost like it's harder than Fermat's last theorem. But in reality it's not going to be that bad because, I mean, if you look at it carefully, right, the 11th power means that probably applying standard number theory techniques like maybe mods may not work that well. So it seems like maybe we can find a solution. So what can we try?
Well, you kind of don't want to experiment when you have A, B, C, and D are all different bases. So you want to make A and B or C are to have the same, to be the same number, or to have the same, be the same number to some power, right? Because otherwise you basically are doing a computer job. You're trying to go through all possible cases. So a smart thing would be to say A is the power of one number, B is the power of the same number, and so forth, right?
So example, why don't we just try, say, power of 2?
Okay, so we can make A, B, C, and D different powers of 2, right? So let's call them like, because one nice thing about powers of 2 is if you add two identical powers of 2, you're going to get the next one, right? So let's call A equals 2 to the power of big A. B equals 2 to the power of big B. C and D.
Okay.
So that means 2 to the 3A plus 2 to the 4B plus 2 to the 5C equals 2 to the 11. So now what do we just, it seems like we're going to have to do some more guess and check to find a solution. Okay?
Well, if the two powers of 2 have the same exponent, they become 1 power of 2, right? So you can probably make 3A and 4B to be the same power. And then you get, maybe, you get only sum of 2 powers of 2. And then you again try to make them having the same exponent.
Okay. So we want our equation to be like, we're adding 2 to the n, 2 to the n, 2 to the n plus 1, and then we get 2 to the n plus 2.
Yeah.
Correct, yes.
So
now they
we need to make 2 of these equal.
Yeah. So we can start trying right now. So say if 3A equals 4B, and then
We want it to be,
5, 6 would be larger.
so n needs to be a multiple of 12.
Yeah. So we need to start with 24 because 24 plus 1 is 25, which is equal to 5.
Yeah, but then the multiple of 11 is going to be a problem because 26 without a multiple of 11. And then, so it means we need to go even higher up.
We're not also have that constraint, so we cannot go on forever. So maybe we can try something else.
Well, maybe instead of trying to pair up these and make guesses, let's focus on this one. Because the 11 is the one that gets big really fast, right? So we need to pick a very small value of d because of our constraint.
Yeah.
So if d equals 1, what will happen?
So n equals 9.
So that means n is 9, right? Because n plus 2 is 11.
And that's only a block 3, so that's not rising.
So d equals 1. How about d equals 2?
D equals 2 is 22, so n equals 20.
Yeah,
so
and that's good because these are both, you can do that. So this will be negative 2 to the power of 20, 2 to the power of 20.
And what about 21 is also block 3, so
that means this works, right? So we pick
A equals 7,
A equals 7,
B equals 5,
C equals 4, and D equals 2.
So now we only to check if this is small enough.
2 to the
So we have
16 to the
2 to the 7,
times
2 to the 5, 2 to the 4, 2 squared. And the multiple product of these three is 2 to the 16,
or 6, 5, 5, 3, 6,
which is
less than 10.
strong enough. So it means that this works.
One thing I can add that, well, that bound was given just to make sure, guys, we will find probably this solution. So the proposers aim to this solution. If you didn't have a bound, as we said, we can find other pairs. And I would also try not only power of 2, also a power of 3. A power of 3 would also work if we make the first 3 numbers equal, right? And
So then we would need like 3 to the 3a, 3 to the 4b, and 3 to the 5c.
yes,
But
and
then we would need all of these to be equal, right? So then we just draw a value of 60.
And
6.
then 61 will work, but 120, 121, because that's
120.
awfully large.
Yeah.
Yeah.
So we have a solution with 120, that's pretty well. Also, these should be otherwise then you can just say 0, 0, 0, 0.
Which is pretty sure it's 0, 0, 0, 1,
Or is it
0, 0, 1, 1.